Hey, and in this video, we are going to be talking about lists in Python. So let's create our file, and we'll call it one_lists.py. So the first thing I want to talk about is, what is a list? So in Python, a list is a built-in, ordered, and mutable collection of data types used to store multiple items in a single variable. So that might have been a lot. Let's break it down just a little bit. Here's what a list looks like in Python. So we're going to say list1 is equal to hello, beans, cool, 1. So built-in just means that we don't have to import anything. So we don't have to install anything from the internet or anything like that. Ordered means that these have a specific order and are accessed using a specific index, which we'll talk about more in a second. Mutable means that it can be changed. And the collection of different data types or collection of data types means that we can have multiple data types in our list. And this is very different from an array. In other programming languages, arrays will only allow you to have one data type. So for example, here you see we have a string, and an integer. Well, an array in other programming languages, or just an array in general, will only let you have a single data type. So we can only have strings, we can only have integers, we can only have floats, whereas a list allows you to have a big old collection of whatever kind of data types you want. And we can store all of these in a single variable, which we call list1. So let's actually create another list, and we're going to call it fruits, and we're going to set it equal to apple, banana, cherry, and date. There we go. And next we want to talk about indexes or indices. So indices, or an index, is the numeric placement of the value in the list. So what do I mean by the numeric placement of the value in the list? So we see we have apple, banana, cherry, date, and these are our values. And now we want to talk about the placement or the index in our list and how we can access these specific values. So indices start at 0. They start at 0 and go until n-1 in the list. So what does this mean? Well, n is equal to the length of the list, and 0 is our initial index. So apple would be considered index 0, and date would be considered index n-1, or the length of our list minus 1. So technically that would be index 3, because we go 0, 1, 2, 3. And the length of our list is 4, so 4 minus 1 is 3. And to access these specific values in our lists, all we need to do is use our variable name, or our list's variable name, and we use the braces again, and we're going to say 0. And this is accessing fruits at index 0. So this is going to be apple. If we did fruits at index 3, we would get date. So when we run this, we'll see we get apple, and then we get date. Another thing we can talk about are negative indices. So if we print fruits at -1, oops, I spelled fruits wrong, we will get date. Now we can access our indices backwards, okay? So we can't start at -0, so instead we start at -1, and this is date. If we do -2, that's cherry, -3 is banana, and -4 is apple. And then, so let's do fruits at -4, oops. And when we run this, we'll see we get date and apple. The next thing I want to talk about is the index out of range error. This happens when you try to access an index that doesn't exist in your lists. So when we say fruits at -5, right, that doesn't exist because we only go to -4. And same if we tried to print fruits at 4, that doesn't exist because we go up to n-1, which is date, or 3. And when we run this, we'll see that we get a list index out of range because we're trying to access an index that doesn't exist in our list. So the next thing I want to talk about is how do we figure out the length of our list. Maybe it's a list that we defined and we read in from a file or something, and we need to determine the length of it. To do this, we use the len function. So len is a built-in function in Python, and we can use that over different iterables. A list is a type of an iterable. So we're going to print, let's say get the length, and we're going to print the len, or length, in our object, which is our fruits list, and it will output 4. Oh shoot, sorry, gotta comment that out. And then when we run this again, we'll see we get 4. So now that we know how to get our length, we know how to access different indices, let's talk about slicing. So slicing in Python is a way to get a sublist of your original list. So say we want to get banana and cherry from our fruits list, or apple, banana, and cherry, and we want to get rid of date and save this into an entirely new list. Well, you can do this using slicing. So let's print fruits at 1:3. And this is how we denote that we want to slice our list. And so when we run this, you'll see we get banana and cherry. Now you might be wondering, okay, we started at index 1, so on the left is our start index, and on the right is our end index. So if we started at 1 and we ended at 3, wouldn't we see banana, cherry, and date? Well, that is not the case because our start index is inclusive, meaning when we use a slice, we keep our start index, and our end index is exclusive, meaning we do not keep our end index in our new list. Sorry. So if we wanted to get from banana all the way to date, what we would do is just type in 4. We can save this and run it, and we would get banana, cherry, and date. Even though 4 technically doesn't exist as an index, it's exclusive, so it doesn't try to access that and save it into our new list. But another way to do this is if we wanted to go, we'll put 3 back here, and then we can also print fruits at 1:. And this is another way to go from 1, so index 1, which is inclusive, this is our start, all the way to the end of our list, which is date. We can do 1:, and that will copy from our start index all the way to our end index. And so we will see, we get, oh, I didn't save my file, I apologize. Always save your file before you run your script. So now I see banana, cherry, and date. That's because we copied from 1 all the way over to our end index. And now if we wanted to copy our entire list, what we would do is say fruits at and just colon. So we're leaving no index on the left and no index on the right. And this tells Python that we want to copy our entire array, or I'm sorry, our entire list. So when we run this, I didn't save my file again. We'll see we get apple, banana, cherry, and date. So if we wanted to save one of these lists as an entire new list, what we would have to do is create a new variable name. And so we'll say new list. is equal to our slice of our fruits list. So we'll say fruits at 1:3. And then if we print our new list, we will see that we get banana and cherry. So remember, start index, end index, but this is exclusive, so we don't take it. And so our new list is an entire new list object of banana and cherry. So the next thing I want to talk about is mutability. Mutability. Maybe I did spell that right. Okay, cool. So lists are mutable, meaning they can be changed. So this means we can add, remove things. We can add and remove things. Sorry. That's all. So let's add something or change something in our list. So we're going to say, if we go back to our fruits list, I actually want to change index 0 from apple to a blueberry. So maybe the user decided to change their shopping list of fruits from apples to blueberries. So we would just say fruits, and then we're going to access index 0, and we're going to reassign index 0 to a new value called blueberry. And now when we print our fruits list, what happens is apple then becomes blueberry, and we keep banana, cherry, and date. And so this is how we assign new values. There we go. And now let's talk about how do we add something to the end of our list. So to do this, we're going to say fruits.append. And using this append function, we can pass in any object we want. And so we can say, for example, we're going to say elderberry. And now when we print our fruits, we'll see that we have another index, index 4, and it will be elderberry. So when we run this, we'll see blueberry, banana, cherry, date, and elderberry. The next thing I want to talk about is how we actually remove a value from our list. So to do this, we will call fruits.remove. And then we want to pass in the string that we want to remove. To do this, we will just say, let's say, for example, the user decided that they no longer wanted to purchase bananas, so they took bananas out of their cart. So we will type banana. And when we print fruits, and we run this, we'll see that banana is no longer in our list. The next thing I want to talk about is the pop feature. So what we can do, what pop does is it removes the last index value from your list. So for right now, our last index value is elderberry. So we're going to say fruits.pop. And when you pop your value from your list, it actually returns it. So we can say last fruit is equal to fruits.pop, and last fruit is going to be elderberry, and fruits is no longer going to have elderberry in its list. So we're going to print fruits, and we're going to print last fruit. When we run this, we'll see blueberry, cherry, date, and elderberry as our variable. And then let's say we wanted to insert something at a very specific index. So we want to insert the value at index 1, per se, right? So right now we have blueberry as our start index, and cherry is our first index. And we wanted to move cherry to index 2 and insert something here in our 1 index to replace it. I'm sorry, not to replace it, but to insert it at index 1, moving cherry to index 2. So we're going to talk about the insert function. So we're going to say fruits.insert. And what we're going to do is pass in the index that we want. So this is index 1. And we're going to say that we want to insert a fig. And when we print fruits and run our script, what we see is blueberry, fig, cherry was then moved over to index 2, and we have date. There we go. And now let's say we want to test if something is in our list. So all we need to do to determine if something is in our list is say our string value or some value. So we'll say fig in fruits. And this will be true or false. So this will return our true or a false. And so we're going to say exists is equal to fig in fruits, and we're going to print fig. I'm sorry, exists. There we go. And when we run our script, we'll see we get true because fig is in fruits. And let's say exists is equal to popcorn in fruits. And if we print exists, there we go, we'll get a false value because popcorn is not in our fruits list. Thank you for watching. Bye. Hey guys, and in this video, we're going to be talking about Python dictionaries. So let's go ahead and create our file, and we're going to call it 2_dictionaries.py. Cool. And first, let's define what a dictionary is. Basically, it's a built-in data structure, just like lists in the previous video. And it is used to store key-value pairs. Now, let's look and see exactly what a dictionary looks like in Python. So let's create a person, and that person is going to be equal to curly brackets. And we're going to have keys, and we're going to have values. So we're going to create our first key as name, because everybody has a name. And we'll call our person Alice. And to add in more keys and values, we are going to use a comma to separate them. And we're going to say age is as our next key, and our next value is going to be 30. And we're going to say is a student is our next key, and that's going to be false because Alice is 30 and she's probably out of college. Not saying you can't go and be a student forever. You can. I definitely know some people who are 30 in college, but for this example, we're just going to say Alice is not a student, and her value for that is going to be false. So just to quickly reiterate, when we create a dictionary, we have our keys and our values. To create a key value pair, we separate our key and value by a colon. And in order to add multiple key value pairs, we separate those by commas. So as we can see here, we have name, colon, Alice. So name's the key, Alice is the value, age, 30 is student, false. And this is what a Python dictionary looks like. Now, there's a couple of considerations we need to think about. And with Python dictionaries, keys are not allowed to be immutable. Are not allowed to be mutable. So what does that mean? Well, I talked about how lists were mutable, and that means they can be changed. So we are not allowed to have a key that can be changed. So you can't have a list as a key in a dictionary, but you can have things like integers, strings, floats, and maybe you can also have tuples, and these are things that you can have as keys, but you cannot have a list or a set. And the sets and tuples are things we're going to be talking about in the next two lectures. So you can learn more about those. Don't worry too much. Just know that you cannot have a mutable key in Python for a dictionary. You can have mutable values, but you can't have mutable keys. So for example, we could say Alice in this person object, her schools were Harvard and Princeton. There we go. So Alice really was an overachiever, and she went to Harvard and Princeton. So you can have that as a value. You can have a list as a value. So you can have anything as a value, but just no mutable keys. So the next thing we want to talk about is how do we access our values. To do that, we will use our accessors the same way we did in our previous lecture with lists. So we're going to say print person, and instead of passing in an index, we are going to pass in our key. So let's say name, and this will print out Alice. So Python 2_dictionaries, and we see we get Alice. And if we print out age, we can print person at age. We can print person at is student. And then finally we can print person at schools. There we go. And if we run our script now, we see we get Alice, 30, false, and our list of Harvard and Princeton. And then if we wanted to access either Harvard or Princeton, what we can do is say at index 0. So what happens here is we are accessing person at the key schools, which gives us our value. And then now we're working with a list, and we are saying at index 0, which is the value Harvard. So if you see when we print schools, we get our list, and so now when we access index 0, we will get Harvard. So when we run this again, we'll see we get our value. Now, accessing values using this accessor is what we consider an unsafe way, because let's say we wanted to access person at a key that doesn't exist, like LOL. When we run this, we are going to get a key error, LOL, and that is bad. So what we do instead is we use the get method or function. So what we're going to do is we're going to say print person.get, and we're going to pass in our value. So we're going to say name. And when we run this, we'll see Alice is printed. But now let's say we misspelled this and we are trying to get NAM. So when we run this, we see that we get this none value. So what is none? None in Python is essentially nothing. It is a representation of nothing. It isn't a real value. You can't do anything with it. You can compare against it, but that's it. So when we use get on a key, it always returns none unless we tell it to return something else. So the second parameter in our get function or get method is going to be our default return if this key doesn't exist. So if nam doesn't exist, we're going to say there is no key with this, or there is not a key. Wow, sorry. This key does not exist. There we go. Perfect. And now when we run this again, what happens is we actually get this key, does not exist. And we run this again. There we go. This key does not exist. And so this is what we consider the safe way to access a key. There we go. And the next thing I want to talk about is how we actually update or add values. So adding keys and values / updating values. Cool. So in our person dictionary, the way we access the value is actually the way that we can add a value or update the value. So we're going to say person at name, so the unsafe way, is set equal to, and we will say Bob. And now when we print person and we run this, we'll see that we get name is now Bob instead of Alice. And now this is the same way that we just updated our value is the exact same way that we can add a new key and value. So we will say person at, and let's say, what's a good one? Likes popcorn is equal to true. So Bob is a very big fan of popcorn. And we print person. and we run this, what we'll see is we've actually added in a new key and a new value. So we have likes popcorn is set to true. The next thing we want to talk about are other useful methods. So what if we wanted to just see what all of the keys are in our dictionary? So we wanted to know what we had access to. Well, we can do this by printing person.keys. So we do this by using our variable name, and we use the keys function, and this will return a list of our keys for us. And so when we run this, we'll see we get I forgot to save my file. There we go. We'll see we get our dict keys list is name, age, is student, school, and likes popcorn. So this is how we see the keys. And let's say we just wanted to get all of our values. So see all of our values. The way to do that is to print person, so your dictionary variable name dot values. And now when we run this, we'll see we get a list of our dictionary values, which is Bob, 30, false, Harvard, Princeton, and true. Another thing you might want to know is how do we delete a key value pair? And we can do that by actually using the del keyword. So how do we remove a key value pair? So we'll say del, which stands for delete, and we're going to say person, your dictionary variable, and we're going to access what the key that we want to delete, which is age. And we'll say we want to get rid of Bob's age, so we'll print person again after removing our age key and value, and we'll run this, and we'll see we only get name Bob, is student false, Bob schools, and likes popcorn, and age is no longer in our dictionary. So cool. That is all I had for you guys in this video, and I'll see you in the next one. Bye. Hey guys, and in this video, what we're going to talk about are tuples. So tuple is a data structure in Python, the same as a dictionary and a list. So the first thing we want to do is create our new file, 3_tuples.py. And we can define our first tuple. So the way to define a tuple in Python and save it to a variable is to do, we'll say fruits is equal to, and then what we're going to do is put them in parentheses instead of braces or brackets. So we'll say apples, and we'll say cherry. Actually, we'll do this singular. So there's only one apple, there's only one cherry, and there's only one pineapple. There we go. And so what makes a tuple different from a list? Well, tuples are immutable, meaning they cannot be changed once they've been created, whereas lists are mutable. So we're going to say, let's actually change this to fruits tuple, and let's create a fruits list and just look at some of the differences. So we'll say apple, cherry, and pineapple. Okay, oops, pineapple. There we go. And if we print them, fruits tuple, and we print fruits list, there we go. And we run this, so python 3_tuples.py. We'll see that one shows up with parentheses and the other shows up as a list. And then if we print the type as well, fruits tuple, and we print the type of fruits list, there we go. One will say tuple and one will say list. So there we go, tuple and list. So let's quickly go over the similarities and differences. So the first thing we talked about, one, our lists are mutable, whereas tuples are not. So what does that mean? Well, with lists, we can add, remove, change some of the values, and in tuples, we can't do that. So for example, if we say fruits list at index 0 is now equal to apples, plural, that will work. And then we print the fruits list, and we run our script, we see apples instead of apple. And then, but if we try to do that, so fruits tuple at index 0 is equal to apples, we'll actually get an error. So we get a type error. Tuple object does not support item assignment. So we can't physically change any of our indices. And so let's actually comment this out so that we can keep running stuff. Same thing for if we wanted to append, right? Tuples don't have the append feature, or they don't have the pop feature where it'll remove any data items. So just remember, tuples immutable, lists are mutable. And what does that mean for our dictionary keys? So let me ask you a question. Do you think that we can use a tuple for our dictionary keys? The answer is yes, because they're immutable. Whereas lists, we cannot use them for our keys because they're mutable. So that's just something interesting to say. And now we can move on. So let's talk about some of the use cases of a tuple versus a list. So when we want to use a tuple, it's only when you want a fixed, unchangeable sequence, like when you want it to be a dictionary key. Or you want to use the sequence for better performance, right? Because tuples actually use less memory than lists. So when do you want to use a list? When you need to modify, sort, or extend the sequence, right? So we can add things, we can remove things. This might be a shopping cart, whereas a tuple might be, a person's name, age, and school that they went to, and you want to use that as a lookup for a value. That could be their tuition payment. I don't know. This is just an example. So, yeah, those are the different ways you should use these. And I'm sorry, those are the different use cases for a list versus a tuple. And so another thing that's very important for tuples is how do you create a single item tuple? So a single item tuple is only when it's exactly what it sounds like. You only have one item in your tuple, but it's actually defined a very special way. So we're going to say single item tuple is equal to, and in our parentheses, in our quotes, only one. But you actually have to have this comma at the end of your single item tuple. You notice that we don't do this here, and that tells Python that this is a tuple, right? Whereas, let's say not a tuple is if we did this without our trailing comma. So we said only one, and let's print the type of single item tuple, and we'll print the type of not a tuple. And when we do this, what we'll see is the first one's a tuple, right? We get class tuple, but the second one is a string. And so this actually just converts this into a string. So yeah, when you want to make a single item tuple, just make sure you have that trailing comma. And that's it for this one. Thanks, guys. Bye. Hey, how's it going, guys? And welcome to this lecture on sets. So sets are a data structure in Python like lists, dictionaries, and tuples, sorry. So let's get started and let's create our file. So we're going to call this for_sets.py. So firstly, let's define a set. So we're going to say first set is equal to, or actually rather, we'll say fruit set is equal to, and to define this, we actually use curly brackets. But remember, in dictionaries, we would have like a key, so like a name, and then a value, so it'd be like pineapple, right? But for sets, what we're going to do is just have a value, so there's no key involved. So we'll call the first one apple. The next one will be cherry. And let's do pineapple. And let's do apple again, okay? So sets in Python, and I'll write this in comments for you guys. So sets are basically an unordered collection of unique items. So what do we mean by unique? Well, if you look at the set we just defined above of the fruit set, we have apple in here twice, right? And so if we print fruit set, basically what's going to happen is because we defined it as a set, it will remove the second apple automatically for us. So if we go ahead and we say Python for _sets.py and we press enter, we see cherry, pineapple, and apple. And I was mistaken. It removed the first apple and not the second one. And so that's extremely important. And that's different than tuples and lists, because you can have duplicate values in each, right? So if we said, list 1 is equal to a list, and we had 1, 2, 1, 2, that's fine. And we print it, we're going to get, if we print list 1, we're going to have 1, 2, 1, 2. Same with the tuple, so we'll say tuple 1 is equal to here 1, 2, 1, 2. These are fine, right? These are legitimately okay to say. Tuple _1. And when we run this again, we'll see we get 1, 2, 1, 2 for both of these. But if we said set 1 is equal to, here we go, 1, 2, 1, 2, all we're going to get is a 1 and a 2. Because that's the point of sets. So set _1. There we go. And let's run it. And we can see we get 1 and we get 2. So that's one differentiation, okay? And so let's say we wanted to, and why is this useful? Well, one programming challenge actually, or question or interview question that comes up fairly often is, given a list of numbers, right? So we have list 1 here. How can you remove any duplicates and just give us the list? And just give us the list without any repeating integer values or something, right? So the way to solve that challenge is actually to say, and we'll just do this with list 1, list _1 is equal to, and we're going to say list, so this is basically typecasting, so we're going to convert whatever's inside of this to a list, and we're going to say set, and we're going to say list _1. So what this does is it converts list 1 into a set, and then it converts the set back into a list, and we assign that to list 1. So what happens is it'll look at the values inside of this list, and it will remove the 1 and the 2, and it will then turn it into a set, and then it will convert just the 1 and the 2 value back into a list for us, and then we can print list 1, and it will only have the 1 and the 2. So if we print that, or if we run our script now, you'll see we get a 1 and a 2. And so that's super useful. That's one common use case for a set. But let's look at some other common use cases. So we basically have these things called set operations. And you can think of some of these as like working with Venn diagrams almost. So let's say we already have set 1 defined, and we can remove this 1 and this 2. Let's actually redefine it. So we'll do that, and we'll just do this. We'll remove the duplicates, because they're going to get removed anyway, and we'll say set _2 is actually equal to 1, 2, 3, 4. Okay. Now, let's say we wanted to combine these two sets into one. Well, we can do this very easily using the union function that sets have built in. So we can print set1.union set2. And when we do that, it will look for any duplicates, remove the duplicates, and just return us with our set. And so let's actually add a 5 here just to make it clear. There we go. And so when we run this, what we're going to get is 1, 2, 3, 4, 5, just like that. And so without any repeating values. And so let's see about the intersection. So let's look at the intersection. And so if we print set1.intersection set2, basically what this is looking for is anything in set 1 and set 2 have the same, return that for me and then print it. So let's run this, and we can see we get 1 and 2 because 1 and 2 are found in both sets, which is a very powerful tool. The other thing we can look at are the differences. So we can look at the difference function. So if we print set1 dot difference set2, this is essentially saying give me a set that is only the values that are different from set 1 and set 2. So for this, it'll be 3, 4, 5, because 3 and 4 are only in set 2, and 5 is only in set 1. And so if we do that, we get 5. Oh, that is my mistake. I am sorry. So this is basically saying that's a different function. So set1 dot difference set 2 is only show me the values in set 1 that are not in set 2. I apologize. So difference only shows the values in the calling set that are not in the comparison set. Again, I'm very sorry about that. So let's actually look at how to do it for both sets. So this is called your symmetric difference. And so to do that, we can print set1 dot symmetric difference set 2. And this will show us 3, 4, 5, or 5, 3, 4, whatever order. So when we run it, now we get 3, 4, 5. And this is because we only want to see, right? Sometimes we only want to see something that is not in the other set, but is in our set. And sometimes we want to see what is not in, or what are the values that are not in the other set for both sets. And so that's where the symmetric difference comes into play, and the difference comes into play. So if we wanted to see, okay, hey, what is not in set 1 that is in set 2, we would do print set2 dot difference from set 1, and then we would run this. And we can see then we get 3, 4 because 3, 4 is only in set 2 and not in set 1. And so now we should figure out how do we add and remove items from a set. So sets are mutable. They can be changed. So it's not, these cannot be used as dictionary keys. So here we go. We can say set1 dot add, and we can add a number to it. So we can add in 10, let's say. And then we can say set2 dot add in 7. There we go. And so now when we run this, it adds those, but actually we forgot to print them. So we can print set1, and we can print set2. There we go. And now when we run our script, we can see we get 1, 2, 10, 5, and 1, 2, 3, 4, 7. And so that's how we add them. And then to remove them, we actually just call the remove function. So we can say set1 dot remove 10, and then when we print set1 again, we will see it without the 10 value. So we press enter, and we can see here we go, we get 1, 2, 5 because it removed the 10. So one important thing to note about the remove feature, or the remove function, remove will cause an error if the value is not present. So that's extremely important. So let's say set1 dot remove 10 again. This will cause our script to error out, and we can see here key error 10. So what we can do instead of remove is something called the discard function. So we can say set1. So instead of calling the remove, we can set 1 dot discard 10, and what'll happen is if the key, or if the value is present, it will remove it, but if it's not present, it doesn't error out, which is ideally what we want. So there we go. You can see we get 1, 2, 5, and when we call this discard function, it doesn't error out. Awesome. Thanks for listening, guys. Have a good one.